Hey, Paul Brownling here, Cisco CCNA in 60 days. If you haven't already, please subscribe to the channel so you see all the other videos. You can drop a comment anytime and I'll answer your questions, and hit the bell so you see all the videos. Day 25, this is Advanced OSPF. You can take a risk and skip this and just go back over the easier OSPF. But if you get asked a question about more advanced topics such as LSAs, then obviously you need to know the answer. So I'll leave it to you because you're taking the exam, not me. Usual drill, review yesterday, watch videos, cram guide, do some subnetting. And today it's OSPF and a lab, but it's advanced. Or more advanced, obviously CCNP and CCIE is even harder. There's 3 books will really help you, all available on Amazon if you want to check them out. Links in the description. So enjoy the lesson and I'll see you tomorrow. Welcome to the presentation on OSPF. A bit of a difficult subject to discuss for the CCNA because OSPF, as you are probably aware, is a huge subject in its own right, and is the subject of many textbooks just focusing on the protocol, even just OSPF for IP version 4. So the presentation was fairly short until Cisco updated the CCNA syllabus to include several other aspects of OSPF. Now the problem you have is you're discussing aspects that were in the CCNP without actually seeing the full picture, because in order, when you start discussing link state types and totally stubby areas, you really need to be able to put it into context and lab it up. But Cisco don't expect you to go into that amount of detail for the CCNA. So it's quite a wordy presentation. You'll have to go through it a few times, but there are a couple of OSPF labs that will hopefully put things into context. So OSPF, it's an open standard link state protocol. The way it communicates with other routers running OSPF is to send hello messages, and what it does is find other links using these messages. OSPF uses link state elements. If you get asked in the exams, typical exam question, it runs over IP using protocol number 89. Now, when OSPF isn't enabled, the network, when it's active, is added to the link state database. Hello packets are used to find link state routers also running OSPF. I've already mentioned the hello messages are used. First type of hello message is used for neighbor discovery. Adjacencies are formed with neighbor routers. Link state database packets are exchanged until all routers agree on the topology of the network. So OSPF uses multicast for updates. It does support authentication, uses MD5, which is a CCNP subject, securing your OSPF route updates. There is support for variable length subnet masking, and networks are divided into areas or subdomains. Now you don't have to. You can have all your routers in one area, but if you do that, then they all must be in area 0. There are exceptions to this, but again, that's sort of outside of the syllabus. Inside the area, link state advertisements are sent. I'll have to go into link state advertisements in a bit more detail. Didn't have to for the previous incarnation, but you do now for the new syllabus. So LSAs, you can consider these the routing updates for OSPF. These help build the topology table, which is referred to as the link state database. Now, so one of the disadvantages of OSPF is when it's first enabled on a network, it's considered very chatty protocol. A lot of link state advertisements are exchanged all over the network until every router has a consistent image. So it can be very bandwidth intensive until the point where it's considered stable by the protocol. So if you have more than one OSPF area, and you can consider an area a set of routers or interfaces under administrative control. They all must have at least an area 0, as I mentioned before. You'll often hear area 0 referred to as the backbone. Now, the way around connecting an area to, if you don't want to connect it to area 0, but you still want it to be part of the OSPF network, is to use a virtual link. But the configuration for that and more theories is beyond what we need to know. Any router that's connected to more than one area is considered an area border router. So it's well worth remembering that term. The types of area you'll encounter in OSPF is the backbone area. A non-backbone area is any non-area 0 area. So it could be area 1 or more. A stub area, there's no external routes sent into a stub area. So this is one of the ways of conserving routing updates within your network. A totally stubby area, only a default route is sent to this area. And these are the sort of questions I'd expect you to get in the exam. Configuring them, again, I've said at the start, it makes more sense once you've configured all of this stuff, but then the configuration part, unfortunately, is outside the scope of the CCNA. Not so stubby areas, they only allow external routes. So the whole point of all of this is to control the thousands of linked state advertisements that could be flying around your network, and it reduces the size of your linked state database. OSPF router types, internal. So all your interfaces are in the same OSPF area. Your area border, I've mentioned, connects to more than one area. Your autonomous system boundary router, what that's doing is redistributing another routing protocol, or it's redistributing an external route into your OSPF. So here's just a diagram. You can see, yes, we've got some external routers here. So router 1 and router 2, are internal routers. So they have all their interfaces in one area. Routers 4 and 3 are backbone routers that have at least one interface in area 0. They're also area border routers because they bridge more than one area. And then area 2 at the bottom, you can see, are also internal routers. They're non-area 0 routers. LSA types, need to know this for the exam, I'm afraid, so it's just a case of remembering it. You have to learn it by rote. This is a summary of the LSA types that you'd be expected to know for the CCNA, and this is where I just find it a little bit strange that they've asked you to know this without actually being able to put it into context by configuring it and doing the debugs and stuff. But you know, I don't set the syllabus for CCNA. So if you're going through this after the first time, I suggest you pause the video and also check the printouts, and you're going to have to learn these by rote. But these are the LSA types that sent within certain areas, and you can see the description on the right. It may also be worth remembering what you'll see if you type a show IP route. You see O, which is shown on the far right of the top 3 or top 2. The area 3 will show as a OIA, inter-area. Same for type 4. Type 5 is O, E1 or E2, external type 1 or type 2. And then NSSA will show as O, N1 or O, N2. Alright, so obviously OSPF can be configured on many different types of network topology you have. You can have a non-broadcast network, which for our purposes really, for the most part, will be frame relay. Point-to-point OSPF networks, broadcast networks, and point-to-multipoint. And these are all to overcome the limitations of these particular topologies. They all deal with traffic in different ways. Well worth bearing in mind that broadcast networks and non-broadcast networks require a designated router and a designated border router. Now, you don't need the backup designated router, BDR. It's not compulsory, but generally you do have them on the network in case the designated router goes down. Designated router, as I said, is required for broadcast or non-broadcast multi-access networks, such as frame relay. Your designated router will listen for updates on a multicast address, which is 224.0.0.6. It floods network updates on 224.0.0.5. Classic exam questions these, so again worth remembering. So if you have a group of OSPF routers, an election will take place between these routers to decide which one is the designated router. The winner is based upon the following: the highest router priority value. So if you configure IP OSPF priority and whatever the highest number is, say 100, then that will win if the other routers have a lower priority. Or it's the highest router ID, which is the highest loopback address. If there's no loopback presence, it'll be the highest interface on the router. So as a repeat of what I said before, designated router will always remain the designated router until there's a reboot. If there's a router with a higher ID added, it becomes the non-designated. It's a non-designated router. So what happens is it won't preempt. You could add a router with a higher ID, but it will not actively attempt to become the designated router. You can recreate an election. I don't recommend you do this on a production network with a clear IP OSPF process and then asterisk. I think that's a space and then asterisk, and then you press enter. So if things aren't working when you're doing practice labs, that is, then this command is well worth remembering. Show IP protocols will reveal your router ID. You can see the router ID here for OSPF's 4.4.4.4. Non-broadcast networks, multicast packets are not correctly forwarded on this type of topology. So you have to statically add your OSPF neighbours. A little bit of a pain this, but it's just the way the technology works. And again, you have the DR and BDR. Okay, basic OSPF configuration, you add the router and then the process ID. This number is locally significant, so it doesn't have to match on another router in order for it to form a neighbour relationship. Again, this could be another way they'll try and catch you out in the exam. You add the network and then wildcard mask, and then whichever area you want this network to be a part of. OSPF will not become active on your router until at least one interface is in the up state. And of course, I've already mentioned before, at least one area must be area 0. So here's a multi-area topology. You need to be able to configure OSPF single area and multi-area. And I said before, if it's not a non-area 0 area, it needs to be connected directly to area 0. Again, there are ways around this, but that's outside our scope for today. So on router A, I will add, obviously I've added the IP addresses to the interfaces beforehand. I've added directly the network 4.4.4.4, and I've added all the zeros, so I want to advertise that specific interface. That's in area 0. The network 192.168.1.0, and I've added a wildcard mask and area 0, and then I've manually set the router ID. In router B, I've added 2 network commands here, and I've added a manual router ID also. And then you can see on the right-hand router, router C, I've added the network for the loopback. I've added the network for the connection between B and C, and I've also added a router ID. The difference here is the network on the loopback, I've added to area 1. So that's a non-zero area being configured. Okay, so same network, and it's just to show IP route. I should have actually done one on router A as well to show the inter-area route being added. But you can see the OSPF areas have now been added to the routing table for router C. You can see the network off router A, the network between A and B also, and obviously you've got connected networks. Alright, basic OSPF troubleshooting. Make sure you've got an area 0 configured. You must have at least an active interface that's up. Classic mistake, and this is 95% of the time, even when I've given labs to students in the classroom and given them the configuration, they've just put a typo in. Wrong subnet, wrong wildcard mask, or wrong IP address on an interface. Silly things, but you know, it can happen, especially in the exam when you're a little bit nervous. Just type a misconfiguration or not spot that two routers have got different subnet masks, or you've put the wrong wildcard mask in, or the wrong area, something like that. Welcome to the OSPF lab. It'll be a fairly straightforward OSPF lab. What I'm going to do, instead of having all of the networks in router 0, over here on router B, this is the same topology as the ERGRP lab, I'm going to add area 1 onto the loopback network for router B. You can see the IP address in, so you can configure that yourself, fairly straightforward. Make sure you can ping from A to B and A to C before you start the lab, otherwise it's going to cause you problems later on. So we'll start with the configuration for router C for OSPF. We're going to do the 10.2.2 network and the 172.20 network. I might refer back to the topology here just to remind myself of the networks. CompT router OSPF, pick a locally significant number, so it doesn't really matter what this number is. The 10.2.2.0 network, wildcard mask. Oops. We need to specify the area as well. Everything's going in area 0 apart from one network up on router B. Now it's 172. .172.20 network. /30 mask, so we need to do a wildcard mask that will target that. Oops, I missed off area 0 again. It's because I've just been configuring ERGRP. Control and Z. Next we're going to router A. Do a show IP interface. Brief. Okay, CompT. .172.20. I think I might have actually made a mistake on the last configuration because I did 172.20.0.0, but I can soon fix that. Area 0, net 172.16.1.0. Again, that's a 30-bit mask. Area 0.
Now it ends in a 192, I think, the 192 network. The mask is 255.255.255.192, so that should give us 63 for our wildcard mask. Okay, Control and Z. Let me just go back to router C because I just want to make sure the network is correct. Yeah, conf T. Router OSPF 100, no network, 172.20.0.0. So I configured that correctly now. And then up to router B. Router OSPF 300, network 172.16.1.0, area 0. I'm going to put the 10 network into area 1. Let me just check on the mask, 24-bit mask. Area 1. Okay, so let's go back down to router C on the bottom and see what we can see. Show IP route. So we can see our inter-area route has come through, 10.1.1.1. We've got the 172.16 network. Our 172.20 network is connected. And if we go up to router B at the top, show IP route, we can see our 10.2 network, 10.20 network is fine, which is going between A and C. 192.168.1 network. So everything's advertising correctly, and because you can see the networks, you should be able to ping all the connected interfaces across the network. Show IP protocols, and it will tell you your router ID, which networks you're routing for, and your information sources, which are the IDs of your neighbour routers. Your own ID, that'll be router C, and this is router B, which is the loopback address.